Good day, students. So on this clip, we're going to be going over an example on how to find the composition of two functions. So let's go ahead and write down the instructions for the notes. For f of x equals 2x squared minus 3x plus 2, and g of x equals 3x plus 1. Find f composed with g of x and the reverse composition g composed with f of x. Okay? Alright, let's go ahead and try the first part, the A part, which is f composed with g of x. Okay, so what on earth does this mean? F composed with g of x. Well, what this means is that we're going to input the input function into the parent function. The function that comes first is the parent function, and this is the input function. So g will be inputted into f. Alright, so how can we re-express that to make more sense? We're going to write f of the input, or the independent function for g will become of f will become g of x. Okay, so f of g of x, that's what f composed with g of x is. Alright, so to do this, I like to start out by writing down my parent function, f of x. But remember, the function that comes first is your parent function, okay? It's 2x squared minus 3x plus 2. Now, for every x in my parent function, I'm going to substitute g, alright? So to get it ready for substitution, I'm going to clear out all the inputs spots, or the independent variables. So f parentheses equals 2. Now let's look at the size of g. It's a binomial of first degree, so let's make a parenthesis that's big enough to accommodate that size. 2 parentheses square minus 3 parentheses plus 2. Okay? The name of the input function goes on the left, and the value of the input function goes on the right. Okay? So our input function, let me write it here again so we don't lose track. G of x is 3x plus 1. So the name, which is g of x, goes on the left side, and then the value, which is 3x plus 1, goes on the right side. 3x plus 1, and then 3x plus 1. Okay? Alright, let's go ahead and simplify this. We're going to have 2, since that quantity is being squared, it's going to be times 3x plus 1 times 3x plus 1. And now we're going to distribute negative 3 to 3x and then positive 1. That's going to yield negative 9x minus 3 plus 2. Alright, now we're going to distribute these two binomials out. So we're going to have first outer inner last, so FOIL 3x times 3x is 9x squared, plus 3x times 1 is plus 3x, and then we can do the inner and last, which is plus 3x plus 1, minus, we can reduce this and this since they were constants, minus 9x minus 3 plus 1 is negative 1. Alright, now let's simplify the quantity in the parentheses and then distribute the 2. So 2 times 9x squared, 3x plus 3x is 6x plus 1. Alright, minus 9x minus 1. Alright, now we can go ahead and distribute the 2. So we're going to have 18x squared plus 12x plus 2 minus 9x minus 1. Alright, now we're going to simplify it further. We're going to have 18x squared is the only square. We'll combine 12x and negative 9x. Signs are different. We'll subtract and keep the sign of the bigger, plus 3x. And then finish it up by combining negative 2 and negative 1, which is plus 1. Okay? Alright, so that is f of g of x. Alright, now we're going to find the reverse composition, which is the b part. So for the b part, we're expected to find g composed with f of x. Now what does this mean? Well, this is the parent function and this is the input function. What this symbol means is basically we're inputting f into g. Okay? So how do we write that? It's going to be g on the outside, which is the parent function, of f of x. So anywhere you see x and g, you're substituted with the function f. Alright? So I'd like to start off by writing what g of x is. G of x is 3x plus 1. And my f, let me put f on the side here. F of x is 2x squared minus 3x plus 2. Okay? Alright, so now we have the parent function. I'm going to get the parent function prepped for the input function, which is f. So g, the name of the input function goes on the left side. And on the right side, I'm going to input the value of the input function. This is a quadratic trinomial, 3 terms, so we need to make the parentheses big enough to accommodate this size, okay? Plus 1. Now, the value of the name of the input function is f of x. And the value is 2x squared minus 3x plus 2. Okay, so let's simplify the right side. We're just going to distribute 3 to all 3 terms. Okay, so g of f of x is basically going to be, to distribute that, we have 6x squared minus 9x plus 6 plus 1. So the final answer, g of f of x, is going to be 6x squared minus 9x, and then we just combine the two constants. 6 plus 1 is 7 plus 7. So there goes your final answer. So basically we now have g of f of x, and then initially we had f of g of x. Alright? Alright, let's go ahead and try another example. Number 2. So question number 2. For f of x equals 2x squared minus 3x plus 1, and g of x equals 2x squared. We're going to do the same procedure. Find f composed with g of x, and the reverse composition, g composed with f of x. Okay? Alright, let's start with the first one. Let's find f composed with g of x. Now what does this mean? This basically means that the input function is going to be g because it comes second, and it's going to be inputted into the parent function, which is f. Alright, so we can write this as f of g of x. So g of x is going to be substituted into all the input values or input positions for f. Alright, so let's go ahead and write out the parent function first. F of x equals 2x squared minus 3x plus 1. I'm going to put the input function on the side. I'm going to write it in blue. In green, sorry. G of x equals 2x squared. Now I'm going to get the parent function prepped for the input, so I'll put out all the x's or input values. So I'm going to have f parenthesis. The name is going to go on the left side, equals 2. Now we have just a monomial, quadratic monomial here, so we just need enough space for one term. So 2 parenthesis squared minus 3 parenthesis plus 1. Now the name of the input function is g, so that goes in next on the left side, g of x. And the value is 2x squared, so put it here 2x squared and then 2x squared. Alright? Okay, now let's substitute, simplify the right side. We have 2 times 2x squared basically means that you're going to square this square and then you're going to square the 2. Both terms will have to be squared, so it's going to be 4 times x to the 4th minus 3 times 2x squared is negative 6x squared plus 1. Okay, if we simplify it further, we're going to have 8 x to the 4th minus 6x squared plus 1. So this function that we have just generated is the f of this is f of g of x. Okay, this is f of g of x. All right, now let's go ahead and do the uh, reverse composition. In the reverse composition, we're going to be doing g of f of x. So let's go ahead and write down the notation first. We're supposed to find g composed with f of x. You can call this is the A part, first part is second part. G of f of x, what does this mean? This means that the input function is f and the parent function is g. So f is going to be plugged into the input function g because it comes first. So that equals g on the outside composed with f of x. Alright? So now, to start us up, let's write down what the parent function is, g of x. G of x is 2x squared. The input function is f. Let's put that aside. I'll write it in blue. F of x is 2x squared minus 3x plus 1. Now I'm going to get the parent function prep for the input. So to do that, I'm going to clear out all the x's. So I have g, parentheses. This is to make space for the name of the input function. And on the right side, 2 parentheses. We have a quadratic trinomial as the input function, so we need to make the parentheses big enough to accommodate the size, square. Okay? Alright, so on the left side we have the name of the input function, which is f of x. And then the value goes on the right side, 2x squared minus 3x plus 1. Okay? Now to simplify the right side using order operations, we know exponentiation comes before multiplication using PEMDAS. So we're going to have to resolve this exponent first. So we have 2 times 2x squared minus 3x plus 1 times 2x squared minus 3x plus 1. Alright, so we're just going to distribute this 3 times and then that will give us our answer, alright? So I'll have, let's do the multiplication first. We have 2x squared times 2x squared. That gives me 4x to the 4th. And then 2x squared times negative 3x is negative 6x to the 3rd. 2x squared times 1 is plus 2x squared. Okay? Now we're going to shift over to distributing the first degree term. Negative 3x times 2x squared is negative 6x to the 3rd. Negative 3x times negative 3x is positive 9x squared. Negative 3x times positive 1 is negative 3x. Alright, now we're going to shift to the 0 degree term, 1. Just distribute 1 to everything. 1 is the multiplicative identity, so nothing changes. We can just put 2x squared here. 1 times that is negative 3x plus 1. Okay? We're going to add everything downwards. Remember, we're still going to double it because of this 2 on the outside. Okay, so after we add everything down, we're going to double it. So it's going to be 2. It's 2 that we're multiplying the whole product by. Comes down here. And then we're going to add this whole business. So add it down, we have 4x to the 4th. Minus 12x cubed. Plus 13x squared. Minus 6x plus 1. Okay? To finish it up, we'll distribute 2 to everything. So that's going to yield 8x to the 4th minus 24x cubed plus 26x squared minus 12x plus 2. Okay? So this is G composed with f of x. Alright, so let's go ahead and box our answer. And that's basically that. Okay? Alright. So thanks so much for taking the time to watch this video. Feel free to subscribe to my channel by clicking up here. Collection of clips can be found on microexert.com. And also feel free to share this video with your friends via Facebook, Twitter, or Google+. Thanks again and have a wonderful day.